Okay. Okay, let's start. Let's do some revision. So how do we define dynamic position or parameter that we use in the dynamics? We look at position, velocity, acceleration, and time. All these are vector. Okay, all these are vector. So the change of position, we call it displacement. Okay. The velocity definition. Okay, what is the velocity definition in dynamics, in engine dynamics? Huh? Not divide time. Time differential. Divide and time differential is different. Huh? It's a time differential of your displacement, right? It's a displacement. Okay, right. Acceleration. What's the definition of acceleration? dv dt. Time is time. So then when we freeze these two, when we freeze the dt, we'll get one more equation, which is a ds v dv. Okay. All right. Now, yesterday in our class, there's three more equations that you need to memorize. It is the Newton motion equation. First one, V equal to VO plus A T. Second one, delta S equal V0T plus 2A, half AT squared. The last one, V squared equal to V squared plus 2AS. All this acceleration is constant. Then only you can use these three equations. So basically, if you know all these few equations, you know this 1, 2, 3, and then these three equations, then you're able to do the question for chapter 1. Now, yesterday we looked at a few charts. How many charts you see yesterday or you learned yesterday? You still remember? How many charts you learned? You learned 5 charts, right? First one is S, T, V, A, and then something S, then V, and AS. Okay. By the end of the lecture, I will cover one question, final question in January that is ask you about ASVS. Okay, and it won't be recorded. Right, the answer won't be recorded as what we did now. Huh? So okay, so this is what we did yesterday. And there's a flow of calculation. If you go from ST to VT to AT, this direction, you do time differentiation, right? You do differentiation. And if you go from AT, VT, ST, you do integration. Okay, so this is the way you memorize things. And then when you draw this diagram, I will highly recommend you mark the time along the tree graph. Right? T1, T2, and so on. Okay, so later I will show you how to do the VS AS graph. You do these two together and then S1, S2. Okay, okay, let's look at this example number 5. Will it still with what you learned so far? So you look at the question. A car travel from rest, travel along a straight line. So you see the word straight means it's a chapter 1 question because you are in the rectilinear, continuous, and it's not continuous. Now it's erratic, means you use graph to represent the motion of the particles, right? So you have the initial velocity. Okay, you have the initial velocity, and it decelerate at 2 meters per second. So it accelerate for at A equal to 10 meters per second square for 10 seconds. So you have the first information. First information is start from rest. You have a V equals 0, means VO 0. Then it accelerate A equal 10 meter per second for 10 seconds. So means 0 to 10. At 10, you have 1 mark for A. Means you can plot AT graph and VT graph. You have 2 information already. Okay. Now, and then deaccelerate. Deaccelerate means it become negative. Negative A. Deaccelerate means slow down or go to the another position. So the magnitude is 2. Although here the value is positive, remember the accelerate is negative value. Okay. Draw the VT-ST graph and determine the time needed to stop the car. So how far the car can be stopped. So I already lay the okay, I already lay the one for you. So try to think like how you can solve this kind of question. Try to think like, okay, first you draw the graph first, of course. You draw the tree graph first because this in this case, although it didn't ask you to draw the AT graph, but it gives you the acceleration. Right? It gives you the acceleration. So it's better you draw the tree graph. You draw ST, VT, AT graph, and then mark the time, time T1, T2, T3. In this case, you have a few information, which is the 10 second, and then you don't know when it will stop, right? Okay. So you draw the tree graph first. So you draw AT graph. Information you have is from 0 to 10, the acceleration constant 10 meters per second. So you draw 10, and then you draw a timeline here, 10 seconds. Make sense? Okay. This is the first graph you generate from the question. Okay. So again, although my slide is on the horizontal presentation, but what I draw on the whiteboard here, I will highly recommend you follow this kind of format. So at least you know how to interpret or how to do the procedure. Right? Because if you move down, you do differentiate. You move up, you do integrate. So it's one of the method you learn how to draw. Then you go to the question, what is the time it needed to stop the car? So you have 1t stop. The car need to stop at certain. No, you can calculate later. Okay. Oh, from here to here, what do you think is the shape of the line that connect this point and this point? Last. So the accelerate at 2 meters per second. So how do you draw? Draw like this. Why the shape is like this? This tell you what? Deaccelerate. Deaccelerate. If you draw this one, is wrong. Huh? Why wrong? Why? Why is wrong if you draw like this? Why? What is this X and Y mean to you? Y means what? Acceleration. X is time. So in first place, how this red line come into the picture? It tell you 10 meter per second acceleration for 10 seconds. So along 0 to 10 is accelerate at 10. If you draw like that, it means what? Your acceleration the accelerate at the what? Constant value. 2. So if you draw a negative gradient line, it's wrong because the question give you one constant value already. So if you draw like this, then it's wrong. So how do you draw the accelerate 2 meter per second square? At where? 8. 8. Try to think, this is also one of the careless mistakes that students do. So you know this one is 10. So the question mentioned this one, accelerate at 2. How you draw on this graph? It's wrong. You know that if you draw a slanted line, it's wrong. If you draw like your friend say 8, why 8? If you say 8, then does it agree with the question? The question say accelerate 2. If you draw 8, means it still accelerate at 8 meter per second after 10 seconds. Ten to 8 up here to 8 like that. 8 like that. What does it mean? It means 10 seconds is 10. What about 11 seconds? It dropped less than 10. Less than 10, less than 10. Again, what is this statement? The accelerate at 2 meter per second. This is a constant value. Constant value. What is your axis? A. Your y-axis is your A. So how do you draw? How do you draw? Huh? Drop to 2, how? Here, drop to 2. Right here, and then? Like that. Value here is -2. Y accelerate at a constant value. Y equal to -2 meter per second square. Make sense? So don't mistake, that's mistakes in the text. Okay. You should draw like that, Why? Question already give you the constant value. Why you go and change the equation? Use the constant value. Okay. So you have two value here. From 0 to 10, your acceleration is 10. From 10 to the object stop is -2 meter per second. So you have three kind of graph. ST, VT, AT. You already have AT graph. The question asks you to convert from AT to VT, VT to ST. So how to do? You do integrate or you do differentiate? You do here to here. What do you do? Integrate. You do integrate. So in the velocity and acceleration, rearrange the equation, pull the t to the left, pull the dt to the left, and then put in the integration sign. To find equation from n to the t stop. Yeah. Okay, first we derive the vt. So as I recommend on the whiteboard here, the first thing you do when you convert, you copy the time first. You copy the time, means you have 10 and you have t stop. All right, copy the two line, 10 and t stop. And then you derive the equation. We have two time slot, 0 to 10, 10 to t stop. Then you expand the integration equation from here. Okay. So next equation you use, you're converting AT to VT. So AT to VT, you do integrate. You're dealing with velocity, time, and acceleration. So go and check these two equations. This one, AT, VT, dt. This one, VS and T. So use this one. All right? So use this one because this one have A, V, and T. So move the dt to the left. Once you move to the left, you integrate, you're able to find one equation on the left and one V on the right. Okay, basically you're deriving the Newton motion equation. Or if you're lazy, you can straight away, but I highly recommend not to use this one. Use the derivation of integration. Okay. Of course, you say, sir, can I use the Newton motion equation to calculate? You can. Why? Acceleration is constant in this case. But if your curve is not constant, it's not straight line, don't use Newton equation. If it's not like that, it's a linear or it's a polynomial or it's a quadratic, then don't come to the Newton equation here. Okay, this is just a very basic illustration. So you use A equal to V dV. You rearrange it in the integration form, right? So you move the dt to the left, you get AT equal to dV. In the integration sign, what is the equation you can get? It's a simple integration. You put in integration sign here. Right? So you integrate A dt. This one, where you look at here. You look at the first slot, t from 0 to 10 seconds. This slot. So basically your A is what? Your A is the constant value 10. What is your limit for time? Look at here, 0 to 10, 0 to 10. Then you continue with the integration steps. Right? Constant value, what you do, you pull the constant value. You left 1 inside. Right? And then 10 and 0. Substitute just so you'll get something like that. Okay, I will show you the answer from the slides. Okay, you integrate means you find the area under the graph. Yeah, means find area under the graph. This area under the graph. This is gradient. So area under the graph, basically, you can do mathematics, right? This is a box. 10 and 10, you get 100. Right. But you still need to show the integration sign, put in the value there. This is an application of integration. So 0, 10, The hardest part is here. This one is V because you integrate with V, not time. So you put V time at 10 seconds. You don't know the velocity here. Okay. But once you derive the equation, you find the V exactly at that T there. Okay, try to get the concept. Then the rest is the same. You repeat the same procedure. Try to understand the principle. Don't chase after the value. The value will change in the test or final exam. Try to think like, okay, now what we are trying to do, right? What equation or what integration step that I need to apply. Okay. So I show you the answer. Same for the second area, which is from 10 to t stop. Still the same. You apply the same integration from here. What you need to be careful is the time for second slot here. Your time here is from 10, not from 0. Careless mistake, some student, they straight away put 0 here. You start from 10, not 0. Start from 10, not 0. So here is lower limit for second half is 10 to t stop. You don't know the t stop, so you just put t stop there. Or you can just put t there if you don't know. Right? Equal to velocity at 10 seconds. So again, on the right hand side is velocity, not time. So the lower limit here is velocity at 10. You don't know the velocity, but you can just put 10 also can, as long as you understand what you're writing. V equal to 10 seconds. Right? Here also, V stop. So you have two equations. Basically, A is a constant value. You can substitute here is 10, but second half is -2 and not +2. Because the question tell you this deaccelerate, so it's -2. So if you have misunderstood the question, you accidentally put this one positive, you already start making mistakes from the step over here. Basically, the whole question you are gone already. So it will snowball. One negative sign will help will destroy your answer. Okay, so we continue by substituting. The rest I think is not very hard. So what you do, you just substitute and then you get the equation. First equation you get from here, you substitute there, you'll get 10t. Okay, because here is a constant you pull out, you get 1, but you're integrating t, so you get t here. You get 10 t equal to v. So this is what kind of equation? Kind of lines on the graph. Remember? Straight line, quadratic line, and polynomial. So what is this equation tell you? It's a linear. Y equal to mx plus c. You see the form? And so this is c. So from here to here, you are actually plotting a linear line. This is in the form of the same comparison is mx plus c equal to y. So your gradient is 10. T you copy because your x is c is 0. And the gradient is positive. So you know gradient of a linear line, right? Positive, it go like that. Negative, it go down. So A more than positive, A less than 0, then it's go up and go down. Make sense? So how to draw? When it's 0, what is your velocity? When it's 0, what is the when time 0, what is your velocity? 0. You need to write in somewhere in your calculation. You need to write T, you need to write somewhere here, T0, V0, substitute here. Then you need to write here, this is V0. V0. Then you substitute t equal to 10 because you want to find the substitute here equal 100. Of course, remember the unit. So go here, 100. Yeah. You put a, then this is a linear line. Makes sense. Repeat the same principle for the rest of the slides. Actually, the procedure SOP is the same. What changes is the numbers and the equation that you derive from there. Okay, now first line, find the second one. What is the shape of the second one? So this one I already explained how to get the 10 and the red line. So I think the correction I need to do here is yeah, I think it's yeah. The equation that I write on the screen here is a bit wrong. Not wrong, but is a substitution of, it is not 10. You see the mistake I did here. It's not 10, it's 8. It's not 10. So don't, when you do your assignment, don't blindly copy. So it's a A and not 10. Okay, you repeat the same for the second half, and there also is a mistake here. This is not 10, it's A. Don't blindly copy. Just need to think when every time you see the slide on the. Okay. So the rest also make correction. Okay. So something like that. There's mistakes in the calculation. Right. So it should be in this way. Should be in this way. You substitute your A value with the time value, and you get the answer. Okay. Okay, next you do the second half. You repeat the same procedure. Okay. You repeat the same procedure. So you pull this one out, you get the AT. This is 1, you integrate, you get the T. Because you integrate T, you get T. Then this one is V. This one is 1. You integrate V, you get 1 V here. We will get the answer here. Now, what is careless mistakes normally do? You will forget starting from second half, and some of you might put 0 here. You might put some value here. This value you find from the previous section. This one. Velocity at 10 here is 100. If you put 0 here means wrong already. You actually put second of the graph here. So be careful on the value you use. Don't assume that is zero. No. In dynamic, most of the time when you start, it's not 0. Right? Because it's constantly moving. Okay, substitute. You get one equation at the end. You arrive at V stop equal to minus 2t plus 120. Again, this one is in what? Y equal to mx plus c. Your y is v, x is t. So you're actually dealing not this problem. You're dealing with y for the time from 10 to t stop. It's negative. So we start from 120 Although, but if you draw the line, it continue from here, right? So draw the line like that, value, you'll get 120. Right? Of course, you don't need to write the 120. What you need to do is this negative line, you just straight away connect this one to this one. Because it stopped now. When the car stopped, what is the velocity? 0. So you look like this, but put in the equation. This one equation, this one equation. Makes sense. Okay. Of course, you want to is y equal to mx plus c. C is the intersection, all right? Okay. So you draw the line. Okay. You can find the t-stop, right? You can find the t-stop, right? From this equation. So you know the velocity at stop. 0. Substitute 0 here. This one unknown. Rearrange, you get t-stop is 60 seconds. So means this value is 60 seconds. So once you find the value, go to the graph here, update your graph, you just write t-stop equal 60 seconds. Okay, nothing complex, it's just that once you have an equation, you can substitute value and apply on the graph. Makes sense. Try to understand why we do a certain step. Okay. Next. So far, okay, So far, understand how we find the t-stop here. By just substituting the value that common sense, because when you stop, v equal to 0. Okay. Now, you have the VT graph already. From AT to VT, you complete one procedure already. Now you continue with the same procedure from VT to ST. So you do integration also, right? Repeat the same, but use different equation. Because now you're converting VT to ST. Use VT, cannot use A equal to VT anymore. You need to use this one. V equal to ds dt, because you are changing VT to ST. So this one doesn't have S here. Doesn't have the position. So you pick the VT equal to ST. Do this one. Then rearrange. Apply the same procedure just now. Remember to write equation on the graph, because it will remind you that actually there is an equation. Then you plug inside the integration. You substitute inside the integration until you find a new equation for the new graph. Okay, I'll show you all the answer. Still the same, draw the ST graph, copy the time line. So it is 0 to 10, and then you know the time already, copy the 60. Same by updating the AT, the AT graph just now. Update the t-stop here. Okay, update the t-stop there. So I'll give you all the answer. Use V equal to ds dt, rearrange it, get into a integration equation. Just need to be careful that you can do it as 2 time slot. Don't do it in one go. 0 to 10 and then 10 to 60. Okay, do it in 2 procedure. So there will be one equation for This is 10 seconds, this is 60. There will be one equation for this region. You need to get one equation. It can be linear, it can be quadratic, it can be polynomial. Linear, quadratic, or polynomial. So that is the concept that once you understand, then you can do any kind of question in chapter 1. You do the same. I give you all the answer. You just put in all the equation. For the first half, your V equation is not a constant value anymore. It's a linear equation. V equal to 10t. Second half, also linear equation, but negative 2t plus 120. So you need to convert this equation into this one. So when you substitute for the first half, substitute here, this one, inside here. Substitute this equation here. Because you're integrating time. So substitute 10t time. Okay. Then for the second half, also same. For the right, arrange, put inside here. Then you'll get new equation. This side kind of equation you arrive at quadratic equation. Because you substitute this equation here, you integrate with time. So you integrate this one, you'll get quadratic. Integrate this one. You break it into two equation steps. You do the integrate minus 2 minus 2t dt plus integrate another side 120 dt. It's a two equation. So here it always pull the constant value up. Minus 2 position. T, this is power 1. You have to integrate 1 plus 1 divided by 1 plus 1. Be this value. Then you have the limit. What's the limit for this one? It's not 0. Limit is 10 and 60. Here is 10 and 60. Second, not 0. So need to the time frame that going to. Because it's 1, you integrate 1, you get something. Right? X and the value of A and B. Okay. Once you get the equation, you draw the graph as what you learned in your mathematics. I'll show you how to do. When you integrate, for the first one, you arrive at S equal to 5t squared. When you do integration, rearrange here and there, you arrive at 5t. So this is quadratic equation. Quadratic equation, y equal to ax squared plus and so on. The A is positive. The A is positive, so it's a smiling face. Okay. How do you draw smiling face? But not concerned about another half. So you look like this. Makes sense? Yeah. The shape of the graph, you have to understand like you are dealing with linear, you're dealing with quadratic or polynomial. Okay. So in this case, it's like that. But the full smiling is like that. But we're not dealing with the negative value. So just use your eraser to erase another half. Okay. Then you do repeat the same. Okay. Now once you have this one, when you have 10, are you able to find the value of this one? How you do? You substitute 10 here. Because this whole equation is a 5t squared. It's T0 S0. Here, you get one value for, it's important, and it's very easy to score marks for the graph kind of question. So you substitute, you get 500. So the value of 500 is appeared in your answer. Okay. Then you do the second half, same. The hard part is you are weak in integration, please go and polish up. If you're very weak in integration, please go and help yourself. Go and do more exercise, polish up, because we have no time to go back to your integration skill. Okay, you arrive at one equation, same, you arrive at one quadratic equation. So quadratic equation, A now, negative. Your negative means set face. How do you draw set face? This is set, right? Center point of the face. All right, just now center face is here. Okay, but remember to erase all those one. Makes sense. Okay. I already teach you how to do this one already, so don't leave it blank when it comes to your test. So remember to write the equation. Can you find from 500 mark? Be careful on the value you substitute. Don't use 0. This is from 10 to 60, not 0 to 60. 0 to 60 means you're assuming this whole curve starts from here. So just be careful on that. That will be the careless mistake also. So when t equal to 60, your S will be 3000 meter per second. Yeah. So means you substitute the 60 here. Because this taxi is following this curve, it takes 60 seconds to reach this time. So you substitute, you get 300. And then when it comes to your final exam or test one, we always like to ask you one question. What is the distance traveled after 10 seconds? What is the distance traveled by the car before it comes to the stop after 10 seconds? Then you confuse already. Maybe you will give 3,000. The answer is take 3,000 minus 500. This is the distance traveled after 10 seconds. Before it comes to stop. Makes sense. That is the way we ask you in the test. So it's not very direct, but you can get the answer from the graph. This is called erratic motion. Okay, and then if you take this into nowadays you have all the smart cars. You have BMW, Mercedes-Benz, Volvo. They come with the safety features. The AI can calculate at what time your car can stop at the obstacles. You have the obstacle avoidance sensor. So it can calculate based on the very dynamics rain data. So before it hit the wall, or hit the front car, he already continue to calculating what is the distance from your car to that object in front. And then it press the pedal for you to slow down the car. So there's a gyro sensor inside there. It manage the velocity, it manage the acceleration, everything combined into what you learned today. It control the computer control the brakes pad and slow down the car exactly before it hit the object. Okay, so don't think that what you learned today is not important. It's very important. and apply in all the sensors now with all these simple calculation. But it's in the dynamic range, means it's continue to calculate. Make sense? Okay. All right. So I will go, I will stop the recording.